Hey, Professor Rogers here. Another quickie video to address issues in our grad stats classes. Um, this is on the topic of mediation and moderation, so we want you to understand the difference of those. This has to do with the possibility of an intervening variable in your hypothesis. So you have a statement that X influences Y in some way, and the question here that we're looking at is a variable T. Uh, If variable t stands between those two variables and changes the relationship, we call it a mediator. If variable t changes the relationship at different levels of the variable or across different categories of the variable, we call it a moderator. Now, the words are kind of hard to understand, so we'll look at an example, and I will look for mediation and moderation in this example. So this data that I'm going to look at is for women. It is from the National Crime Victimization Survey. We're looking at the years 2009 to 2019. The question that I want to know about is, do women report incidents of violent crimes? We're specifically concerned about in our time with the public discussions about race and policing about whether Black women feel comfortable to contacting police to report violent crimes. This analysis that I'm doing is a binary logistic regression, and I ran it using the generalized linear models procedure in SPSS, the one where you can customize the model. And I'm doing that because that is where it's easy to make an interaction term for the binary model. Here are the results of the basic equation. So what we see is the likelihood of reporting increases among Black women when we compare Black women to non-Black women. If we look at the exponentiated B, which is the third column from the right, we see a value of 1.325, which says to us that Black women are 32.5% more likely to report an incident of violent crime than non-Black women. Well, that seems kind of odd, doesn't it? That seems contrary to everything that we hear in the media. So I took another step. This was actually proposed by one of my colleagues who I'm looking at this question with, and my colleague said, well, has things changed since the incident in Ferguson, Missouri several years ago? So we've created a dummy variable before and after the Ferguson event. And I have underlined that here at the bottom. We look at that row and we see that Ferguson does reduce the likelihood of reporting. I'm saying it causally, it's not really causal. We're saying after Ferguson reporting is less likely. We're assuming causality, but by that event, but that may not be true, but that's what it looks like. But when we look at the variable Black, we see that the exponentiated B doesn't change much. So the percentage went from 32.5% down to 31.7%. So it's not a big change. Now, the way I introduced the post-Ferguson variable here is I introduced it as a mediator. So I'm looking for it, in my case, to see if it will cancel out the association between race and police reporting. Now I'm going to look at Ferguson as a moderator variable. And there's two ways we can do this. The first way is to split the file into the pre-Ferguson events and the post-Ferguson events. And you see that on the far left. We see post-Ferguson no, post-Ferguson yes. Now this is a simple command in SPSS. It's in the data menu, and I set it up so that I could compare the two groups. So I can look at the two groups and go over to the exponentiated B pre-Ferguson. Black women were 42.2% more likely to report than non-Black women, and that drops to 22.8% after Ferguson. So there's a big drop there. This suggests that the Ferguson event might be moderating, that the reporting levels of Black women are different before and after Ferguson. I can create a statistical test for that to see if that difference is statistically significant. To do that, I go in the model statement to the and create an interaction term. So in the middle of the page where it says build terms types, that's by default set to main. I'm going to switch that to interaction, and then I'm going to move everything over. Now, when we test an interaction effect, we include the main effects. So the main effects are this race E4 cat 2 variable, that's Black. Then post-Ferg is my post-Ferg variable. I slide each one of those over individually from the left box to the right box. And then I slide both of them over together. So I make both of them gray and I slide them over together. And that's that third thing that I see there on the right side, where I have the race category and post-Ferg separated by the asterisk. That means multiply the two together. So if the individual is Black and the event occurred after Ferguson, that's going to create a 1. And if it's anything else, it's going to be a 0. That's going to be able for me to highlight that specific effect. So this is what happens with the model. I get the two main effects that come out. And then I also get my interaction term. And I highlighted the interaction term here. You'll notice that there is a decrease in reporting after Ferguson with my interaction term. But look at the statistical significance, 0.105. So it is not that difference that I see is not statistically significant. So this is the statistical test for moderation, but I'm going to conclude that there is not moderation. So in this analysis, I concluded that the Ferguson variable is neither a mediator nor a moderator. Now, you may want to do some of this testing in your projects for this class or in other settings. This could need more columns on your table. So in another video, I show you how to put the unadjusted and adjusted models side by side. But now you may need additional models. So we may want to have a model with the interaction term added to the adjusted model so that we can see whether or not there is a Ferguson effect. Again, as in all this stuff, you don't stick tightly to the format of the reporting. The thing is to use the reporting to show what you're doing. So sometimes we do highlight mediation and moderating effects as separate columns in our results if that seems appropriate. That's it for this video. Have a good day.